little bit more. It's the last talk, you guys, and then it's done. Then it's done. Thank you so much to Chris and Mina for inviting me to come speak at this wonderful conference. I have to say that I haven't really spent a lot of time in Dallas before, and I got to spend the last couple of days hanging out in your town, for those of you in the audience that are from here, and it's a really cool town. And I'm really amazed at all the things that are just starting to take off here in the world of tech. So yeah, y'all should be really proud. It's an exciting time. So this is my talk to the moon and back. Little introduction. My name is Julia Elman. I am a designer-developer hybrid. Done Python, Django, HTML, CSS, JavaScript for about over a decade now. And I'm originally from Kansas City. Go Royals. Yeah, that's right. And yeah, so I do a couple things. I currently now live in Raleigh-Durham, North Carolina. I'm one of the co-leaders and founders of Girl Develop It, Raleigh-Durham. And yeah, we started in January 2013. We have over 850 members right now, all women. And we have classes on everything from salary negotiation to HTML, CSS, R, Python, and many more. I highly recommend talking to Mina about the Girl Develop It chapter here, because they're up to some awesome things. And last week, I just founded PyLadies. So I think there were some PyLadies in the audience earlier. Was I correct with that? No, totally wrong. So I founded PyLadies, which is an organization that focuses on getting more women into Python programming, and started a chapter in the Raleigh-Durham area. And we had a kickoff party. So, and on that note, what I actually got into Python was when I worked at the Lawrence, Kansas Journal World, at the World Online, where Django was created. For those of you who don't know what Django is a Python-based web framework, kind of similar to Ruby on Rails, but in the Python world. And with that, and having the experience that I've had, I decided to write a book. So somebody in the audience won it, and we're almost done. We're at the final stretch, and I have some cards up here for 50% off the ebook. If you're interested in getting that, just come see me after this talk, and I'd love to give you one. So I've left this slide intentionally blank, because we're going to be talking about some big issues here. And I want to just take a moment to think about that. Just take a moment, because we're going to be discussing the past, present, and future of solving big problems that make a global impact. So let's start off with the past. Let's take a trip back to the 1960s. It was the beginning of the Civil Rights Movement, the Vietnam War, and the hippie generation. President Kennedy took leadership in 1961, and he started his term with his famous moon speech. That was on September 12, 1962. He shaped the dreams for space with this famous speech, and he piqued our nation's interest in space. He created a vision beyond what the world ever thought it was capable of doing. We are going to walk on the moon in this decade, he said. And on July 20th, 1969, that dream became a reality.
At 15 seconds, guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. We have a liftoff. Liftoff on Apollo 11. Shadow. 4 forward, drift into the right a little. 30 seconds forward, drift. Contact light. Okay, engine stop.
Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue.
We're going to be busy for a minute.
Armstrong is on the moon. Neil Armstrong, 38-year-old American, standing on the surface of the moon. on this July 20th, 1969.
That's one small step for man, one giant leap for mankind. Oh, that looks beautiful, clearly. It has a stark beauty all its own. It's like much of the high desert of United States. It's different, but it's very pretty out here. Beautiful, beautiful. Isn't that something? Magnificent sight out here. Magnificent desolation. Tranquility Base, Houston, guidance recommendation is pinged, and you're cleared for takeoff. Roger, understand. We're number one on the runway. 7, 6, 5, engine arm active. Beautiful. Very smooth. Very quiet ride. Apollo 11, this is Hornet, over. Apollo 1, this is Apollo 11, reading your loud and clear. Our position 1330.
Anyone alive during this time remembers the amazement and wonder and the hope and what far-stretching goals the human race could and had accomplished in just a few simple steps. This age became the dawn of a new era. We gained a whole new perspective of the Earth and our surroundings. This image right here is taken from the Apollo 8 mission, and it's called Earth Rising. Before then, no representation of the Earth depicted it as having clouds or an atmosphere even. You can see our newfound awareness in the years following the landing on the moon. So let's take a look at that timeline. So in 1962, John F. Kennedy gave his famous moon speech at Rice University. And in 1969, that dream became a reality. It's interesting to see what happens after that. In 1970, the EPA was founded, the Comprehensive Clean Air Act was signed, and Earth Day was founded. In 1971, Doctors Without Borders was created. Now, where do you think the term without borders came from? Could it be possibly the founding of the Earth's atmosphere and around it? In 1972, the Comprehensive Clean Water Act was signed and DDT was completely banned. Think of how much changed in such a short amount of time in the human race. Advancements in policy, technology, and the motivation to move the human race forward with endless possibilities. The world started to have a new energy and hope for the future. You can see these in the events following the moon landing and how it shaped those years to come. Now let's fast forward to the present. Technology has taken over most of our daily lives and what most of us in this room make a living at. Now, what great strides and efforts are we making to that of the 1960s? I'm going to show you an article that struck me and motivated me to write and give this talk to you today. So this is the November-December 2012 issue of the MIT Technology Review. And does anyone know who that is in the picture? Anyone? Anyone? That's Buzz Aldrin. That's one of the 3 men that walked on the moon on the Apollo 11 mission. And his face completely says it all. Utter disappointment. So what happened? What happened to make Buzz so sad? I'm going to run through a couple of different scenarios from the article itself that may or may not explain things a little bit. So the first thing a lot of people think about is Silicon Valley. Can we blame Silicon Valley for the reason why we're not solving globally impactful issues? People say there's a real lack and sense of innovation coming out of Silicon Valley, and worry that technologists are more obsessed with trivial toys and gadgets. Now, the driver for Silicon Valley is venture capitalism. And venture capitalism investments help fund these new types of technologies. And we started focusing more on the personal computer revolution in the 1990s. To combat this, the Founders Fund was created in 2005 to help drive innovation and start investing in solving big problems. It was founded by Peter Thiel, Sean Parker, Ken Howry, Luke Nosek, and Brian Singerman. Some of these names may sound familiar as the founders of PayPal and Napster. By 2011, they raised more than $1 billion in aggregate capital. Things like Causes, Vodafone, and SpaceX were part of that. So can we really blame Silicon Valley for these issues of why we're not solving these problems? A little skeptical. So venture capitalism has always struggled to solve big problems because it's a risk investing in something that doesn't have an immediate return. For example, biotech and energy. It's a huge payment up front with no certain time lapse, and it's risky without economic value, which usually equals no funding. So what really happened? Let's put the personal computer revolution aside here. We solved big problems once. What really changed? Let's run through a few more ideas. Another reason that we fail to solve big problems is institutional failure. Our institutions fail to help promote and create those solutions. An example of that is, it's a little hard to read there. What it says is less than 2% of the world's energy consumption was derived from renewable energy. Now, that was in 2010, and that considers things such as wind, solar, and biofuels. The reason is economic. Coal and natural gas are cheaper than solar and wind. Petroleum is cheaper than biofuels. Now, we need these renewable technologies that could compete with the price of coal, natural gas, and petroleum. And at the moment, that doesn't exist. Another reason why we fail to solve big problems is that we over-engineer the solution. In 2012, malaria killed more than an estimated 483,000 children, according to the World Health Organization. That's 1,300 children every day, or one child almost every minute, primarily in African children. To combat this, Mr. Bill Gates and his friend Nathan Myhrvold got together and helped promote and funded research to help fight the battle against malaria. They did things like create better vaccines, genetically modified mosquitoes, and this is for real, mosquito zapping lasers. There's actual video, you can watch this happening. Now, the most effective cures they found are much more simple than that. Eliminate standing water, drain swamps, provide mosquito nets, and most of all, increase prosperity throughout the region. Combined, these simple methods have proven to be very effective in combating the disease. Another reason why we fail to solve big problems is that we don't really understand the problem. In 1971, President Richard Nixon declared the war on cancer and signed the National Cancer Act. But soon thereafter, discovered there are many different kinds of cancer that are fiendishly resistant to treatment. And it's only been in the last decade that targeted therapies have been created in order to combat these different kinds of cancer. Hard problems are hard. Yet we were able to fly humans to the moon. They walked on it and came back. Now, why was that successful? Now, we can solve big problems if these three things are in line. Number one, our institutions support its solution. Large organizations investing time, energy, and funds to solve big problems For example, investing in new and sustainable technologies. Number 2, we actually understand what the problem is. Broader research, scientific and computational evaluation of that problem that create targeted solutions and that we try to understand to the best of our ability. Number 3, active political leaders making statements for change, creating policies that coincide with that change, and actively engaging the public towards collectively solving that problem. The list of hard problems is ever growing. Rapid climate change, poverty, access to clean water, disease and epidemic, human rights violation, and access to quality education. So how can we help? What can we even start with? And who the heck am I to even tell y'all any of this? Well, what I can talk about is something I've been working on in my local community. Let's talk about education. Now, the color's a little hard to read here, but can anyone tell me what that is? What kind of prompt that is? This is Logo. And this is the first programming language I learned when I was 7 years old in a little tiny little school in Kansas. And you can do things like this. You just like draw boxes and shapes and stars and crazy psychedelic trees that you were super excited about to show your friends. And it really started my journey in computational thinking. Now, what is computational thinking? Computational thinking is a set of problem-solving skills that we as software engineers and developers use in order to solve big problems. Now, it's set into different parts. One is decomposition, which is where you're taking a large problem and separating it out into smaller, more manageable chunks. Another is pattern recognition, where you help identify similarities between objects. Another is algorithmic design, which is a step-by-step strategy to solve the problem. Now, why is computational thinking important? Think about it. Today's politicians, police officers, teachers, journalists, and CEOs are being created today. We need to teach this new generation computational thinking because of the technological age that we are all living in and that they're being raised in. Now, therein lies another big problem. So in the state that I live in, North Carolina counts computer science as a core graduation credit. But it also ranks as the worst state in the nation for teachers' pay. That's 13% of North Carolina teachers left their jobs in the last year alone, and has reached a 5-year high. There's a lack of job security, making it more difficult to retain these quality teachers who could possibly help promote these tech advancements and programs within their schools. So in 2012, helped volunteer at something called the Teen Tech Camp that refreshed the Triangle, which is an organization put together in order to give back to the local community. Partnered with a local library where kids got to actually learn basic things like HTML, CSS, and a teensy-weensy bit of JavaScript. But during the day, one of the volunteers brought in a book on Python and Raspberry Pi. And the students were really interested in it, but we didn't have the infrastructure set up that year to actually do anything. Kind of just like threw everything together and wanted to see what happened. So in 2013, at PyCon, which is it's the national Python conference in North America, did something called the Young Coders tutorial, in which kids ages 9 to 18 learned Python programming on a Raspberry Pi. So I was involved with this slightly and decided to bring it back to the Triangle, the area where I live. I got a whole bunch of volunteers together, librarians, developers, designers together to kind of help get things going. We had weekly hangouts, Google Hangouts to keep things in check. We wrote a grant to the Python Software Foundation to help fund and promote and get Raspberry Pis and computers for all those kids that were coming, and also create curriculum. This is a picture of the day before the event where we took all of our donated monitors, keyboards, mice, let's see, Ethernet cables, and I think somebody gave us like a 48-port switch of some kind. And yeah, put everything together. And it was great because it was a sense of the community coming together to actually do something. It was a vision that we created together. And the night before, it was really cool to see all these little Raspberry Pis asleep, ready for these kids to come in the next day. And man, did those kids come in. They came in ready and eager to learn, each one of them. We taught them very basic, very simple things, like, you know, basically getting to the point where they could write a simple function in Python via command line or an IDE of some kind. And the end of the day kind of looks something like this. Now, I don't expect each and every one of these kids to leave being a professional computer programmer and knowing everything about Python or Raspberry Pis, but I do want to get them excited and wanting to learn more. Because in the end, the cool part is when one of your students actually gets excited and inspired and sends you a video of something they created, which looks like this.
So basically I've hooked up this ultrasonic sensor right here to my Raspberry Pi, and then it has a program on it that will measure the distance with the ultrasonic sensor, and if the distance is less than 30 centimeters, this green LED turns on. If it's in between 30 and 50 centimeters, the blue LED turns on, and if it's greater than 50 centimeters, the red LED lights up. So it works like, and then the program ends after it loops through that 200 times.
This is what I feel is my moon landing. I feel a responsibility to really teach this new generation that we're bringing up in this technological age and teach them computational thinking and programming. So let's say you want to contribute. I'm going to run through a few different places that you can actually teach and or code. So let's start with teaching. So there's a couple different organizations I'm going to point out here. Some local, some national, some that I've mentioned before. One is called code.org. How many of you have heard of code.org? Y'all should all be raising your hands. So this is something that just started last year, and if you want to check it out, just go to code.org, and they do an hour of code that's coming up in December. It's a big international event in which they have curriculum, they have support for you all to get together and teach kids an hour of code for the whole week in various different schools, and there's support for that. Another one is called Black Girls Code, which some of you may or may not be aware of. I saw that there was an event here. It was an HTML and CSS class that was actually taught. There's not a chapter here, but I think there's rumblings that there may be one starting. So if you're interested in teaching or helping out with that, I highly recommend getting in touch with them and saying that you're interested in helping to help with their mission to increase the number of women of color in the digital space. And the age range is between 7 and 17. Another one is Girl Develop It, so one that's near and dear to my heart, we really exist to help provide affordable and accessible programming for women who want to learn how to be programmers or make a shift into it. So if you're interested in helping with that, there is a Dallas chapter. You can talk to Mina Markham, who is around here. Mina, are you in the audience? Are you here? No, she's not. Yeah, there she is. You should go talk to her and see about classes that she's offering. She's doing some awesome stuff. So definitely check it out. Let's say teaching's not your thing and you want to be coding. There's lots of stuff you can do with that. Here's a couple of them. One is called Code Montage, which empowers coders to improve the impact on the world and connects organizations with volunteers. They fund things such as USHA ID, Digital Democracy, and the Sunlight Foundation, all amazing organizations that you can contribute and volunteer your time to. They do a Coder Day of Service, which is coming up in January of this upcoming year, and we can spend a day and do a Coder Day of Service in order to contribute your talents to. Another one is called Code for America. Now, Code for America has 2 chapters in the state of Texas. Not chapters, I believe they call them brigades. They have one brigade in Austin and another one in Houston. There is not one in Dallas. If you're interested in joining Code for America, they focus on bringing local governments and technologists together to make technology better throughout their cities. Like, how can you make technology, things that use technology better throughout the city? So if you're interested in starting one, or if you want to join something in the Austin-Houston area, I highly recommend it. It's a fantastic organization. Another one is called Hack for Change, which does a national day of civic hacking that brings together technologists, entrepreneurs, developers, and designers with other citizens and figure out what they can do with your talents to make things better throughout your government and your cities. So it's this last year, it was the end of May to the beginning of June. It had 123 events throughout 103 cities. So this is a national sort of week-long thing that you can participate in and start and volunteer with. I kind of ran through a lot of those because we're running out of time. So I will post those, I will tweet those out at Julia Elman on Twitter, so you can look those up later. So start simple, but start. Start with something that you're definitely passionate with, but pick something that's meaningful to you. Your talents and gifts are incredibly valuable to the global community. Help open up the dreams and opportunities for our future. And let's build tomorrow together. Thank you.